Welcome to our discussion of data interpretation questions. As the name might suggest, you're going to be given some data on these questions and asked to interpret it and then do some math with it. So, for the most part, the math that you do on these questions is going to be the math that you do on fractions, decimals, and percents questions. You just have that added step of having to pull the data off of a chart. And the charts can take several different forms. Bar graphs, pie charts, line graphs, and tables are the most common among them. And tables are probably the easiest to work with because they give you the numbers directly. No interpretation of more visual representation is necessary. But an important theme for this segment is, while you can use your calculator to figure out fractions, decimals, and percents, you still want to be intelligent about when you use it. And for the most part, intelligent calculator use means calculator use along with approximation, smart plugging of numbers into that calculator, as well as verifying your calculator results with common sense, always doing kind of a sanity check whenever you use the calculator. So the big thing on data interpretation is the added time that interpreting the graphs will take you. For these questions, you should aim for an average of 2 minutes per question. So if you're going to see 3 data interpretation questions for a given set of graphs, you really have 6 minutes for that whole set. It's nice that you get 3 questions on the same set of graphs. It means, once you have an idea of where everything is in those graphs, you don't have to reorient yourself to a new set of graphs to answer another question. So one set of graphs, oftentimes one general interpretation at the beginning so you know where everything is. So about that 2-minute time average, that is what you should aim for on the test. In this lesson, some of the questions are, I think, a little faster to do than that. For one thing, in some of these, I'll be giving you one chart instead of a whole set of them. And some of the questions are designed to illustrate, one theme or one takeaway. And as such, they're a little bit faster than regular test questions. When that happens, I will give you 1 minute on the clock. Towards the end of the set, I'll throw some that are more test-like, more than one chart at a time, more challenging questions. And for those, we'll aim for about 1:45 to 2 minutes. And I will give you a timer as you work. So this is our first one, a 1-graph problem, so I will give you 1 minute on the timer. All right, welcome back. And one huge recommendation for you is that before you start diving into the numbers and start plugging things into your calculator, focus more on the words. In doing so, you'll focus on finding the right information. So the words in the question talk about how many crates of oranges. And we should note the dates there, 1985 and 1983. Are just 2 of the years given. But where do we find crates of oranges? For one thing, you can match that up to the header of this graph. The title says this is giving us the number of crates of fruit. Oranges and apples are those two kinds of fruits, and so pay special attention to which one of those is oranges. It's the lighter shaded bar. On stacked bars, you want to be really careful. Oranges are on top, but the number of oranges is not where the bar reaches. So watch out and beware. Don't use the top of the bar in stacked bar graphs. If you did that here, the difference between 85 and 83 is 1,000, right? They directly correlate to 6,000 and 5,000, and that's a trap. To find oranges, we actually have to subtract out the apples from them. And you can do that kind of visually. Just look at the difference between, the top of that light gray part of the bar and the bottom of the light gray part of the bar. And so that's almost exactly 2,000 in 1983, a little bit less than 2,500 in 1985. And so that corresponds to a difference of a little bit less than 500. Okay, so notice that I'm being a little bit imprecise because we don't have any labels between 3,000 and 4,000. I don't exactly know how many apples there were in 1985. You kind of have to eyeball it, and that's okay. And notice the use of the word approximately in the question, acknowledging that that's okay to do. All right, same chart, second question. Again, I'll give you a minute on the timer. On this second question, we're more familiar with the graph, but it's still worth checking the language, okay? Again, we're looking at number of crates of oranges, so we're going to focus on that top part of the stacked bar again. And this time we're comparing the years 1980 to 1983. So we already know we need to back out the apples from those totals, right? So looking at the light gray part of the bar, we're looking at an increase from about 1,500 to about 2,000. Now you may be able to figure out the percent increase in your head. What's the percent increase from 1,500 to 2,000? Well, you're increasing 500, which is about a third of the original amount. So that corresponds to B, but you can explicitly use the percent change formula for this. And notice that the other choices are really far away from that. So even if we're doing a little bit of approximating as we determine those numbers, the percent is pretty reliable. All right, this question will introduce pie charts, and we will see several questions on this same chart. So I'd like to keep us moving. I may give you only 45 seconds on each of the problems associated with this one, but for the first one, I'll give you a minute. All right, so in a pie chart, the various segments of the pie comprise the total, so your percents will add up to 100%. There are some exceptions when they don't quite add because of rounding, but usually I think that's noted and you don't need to worry about it too much. Again, let's focus on the words first. Make sure we're looking in the right place on this question. We care about how many Nissan Brigadoons and how many Chevy Diphthongs. All right, so we go to find those on the chart, and those are those two segments. Now, those are given as percents, and we want number of cars. So one way you could do this question is to take those percents out of the total. We're given that 100% of the cars is about 806,000. And on screen, I'm showing what I think is like the worst way to use your calculator. You are taking those 2% individually. You're not approximating the 806,448. It would be perfectly fine to approximate that as 800,000 cars. And so this is really, really, really the long way. You end up with two awkward numbers, and you have to do another final step, which is to look at the difference between them. A much better way, smart calculator users will subtract the percents first, right? It's 29% of the total versus 17% of the total. Well, that difference is 12% of the total. Do that, and then you end up taking only 1%. You can calculate the difference directly. And notice that, approximating gets you in the ballpark of the numbers. And even a sanity check is possible. You don't strictly have to use the calculator here. We know we're looking for 12%. And so 10% of 800,000 is about 80. Our answer needs to be greater. Only one answer is. All right, so a way to pick up some time. All right, same chart, different question. So I'm going to give you a very brief amount of time. Take 45 seconds. All right, kind of a similar question. This time looking for the ratio of one kind of car to the number of another kind of car. So orient yourself in the chart. We want Nissan Brigadoons and Chrysler Picanti this time. And there's another shortcut available here. So very similar to the last question. We don't need to figure out the number of cars first before thinking about the ratio. Why not? Because what we're looking for is the ratio of Picantis to Brigadoons. So we put 6%, the Picanti amount, on the top. But notice that we're taking a percent out of the same total each time, so this can cancel. And furthermore, it's a percent each time, so percent on top and percent on bottom can cancel. So what we're really looking at is a ratio of 6 to 29. What is that approximately equal to? Well, it's about 6 to 30, which reduces to 1 to 5. And that's just various ways of expressing a ratio, both as a fraction, kind of an over-under fraction, in words, 6 to 5, or 1 to 5, or 6 to 30 equaling 1 to 5, and finally with the colon, just another way of saying that. This is the third question for that same chart. So again, I'm going to give an abbreviated time frame. There's also a shortcut available in this one. So aim for 30 seconds on this one. On this question, do not take the various percents out of about 800,000 and figure out how many cars there are in each category and see which one gives you 100,000. No, use the 100,000 from the outset. Figure out what percent that is of the total and then just match up the total or the percents. All right, so 100,000 is what percent of 806,000? It's about an eighth of the total, which you may just know offhand is 12.5%, or you can plug that into the percent formula. And that's actually a little bit on the high side because the total's actually a little bit bigger than 800,000. And so what's the closest category? Hyundai Philately. There you go. And it's the only one in the ballpark. All right, one more. Take 45 seconds. All right, so let's orient ourselves to which part of the graph to look for. Focusing on the words, Toyota is what we're looking for, its share of the pie chart. They tell us that 2% share increases by 50%. Now, that doesn't mean it becomes 52%. It increased 50% relative to what it was. All right, so 50% of 2% is 1%. That's how much it grew. And so that becomes 3%. What else is going on here? The total number of cars owned by all the citizens remains the same. Okay, so that number that we've been working with all along, we're still going to keep on using that one. All right, so if this change happened, how many of that kind of car? Well, it's just a percent. So plug into your calculator. Don't be real precise about it. And you end up at 24,000. So notice the big trap is not just like, it's not about are you off by 100 or by 200. It's whether you're off by like having an extra zero in there, whether you're off by a factor of 10. So a quick sanity check, 1% of 800,000 is 8K. We expect something 3 times larger, not 30 times larger. So watch out for that. All right, new chart. New question. I'll give you a minute on this one. And because the timer would probably block our view, you won't see that on the screen. All right, that's been a minute with this chart. And median is the middle value when the values are ordered from low to high or from high to low. How do you find that from a chart? With a list, you've got your list of numbers. You can just rewrite that list in order on your page and then just pick out the middle number. it's a little harder to do that. You definitely don't want to look up all the different points here and write down a list of numbers, especially since there's 19 different years that we're looking at here. So to find the number of years, we take 2000, the latest year, minus 1982, the earliest one, and then we add one before we're done to account for the fact that we are including 1982 in this chart. Okay, so in 19 years, the median would be the 10th highest or the 10th lowest year. Notice there would be, the 10th year would be the one with 9 higher than it and also 9 lower. But that's not the 10th year chronologically. It's not 1991. It is the 10th year when ordered by magnitude. So how do you pull that off of the chart? An easy way to do that is visually. Just cross off mentally, that is, the 9 lowest terms. So, sometimes in my mind, I think of a horizontal line and it's rising, sort of like a water level in a bathtub would rise. And, I'm crossing out the points I come across as that line rises. And once you've crossed out 9 of them, your 10th point is the one you focus on. And I think just to serve as a double check of this, that you've picked the right point, I would do a quick double check. Are there 9 points above this? Yes, there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we know we have our right year and our right point. The last thing to do is just interpret the scale of the chart. So the vertical axis is given to us in the title. That's millions of metric tons. That's the units they ask us for in the choice. And we know the numbers between 4 and 5. Here we actually have additional marks, and there's 5 of them per unit, per integer. And so those are increments of 0.2, and our answer is going to be 4.2. All right, here's where we're going to get it into those sets that have more than one graph at a time. And we're going to see several questions on this particular set. So here's where I'm going to give you a little bit more time. I'll give you 1:45 for this one. I think it's somewhat normal to spend longer on the first question of the set a set of charts because you have to sort of figure out where to go. Later questions may be phrased in a similar way. You already have some sense for where to go to find your data. So for the later questions in this set, I may give a little bit less time. So hopefully you used your time well, just to kind of observe the graphs and really dig into it if you had extra time. Okay, so first thing is we're dealing with people at least 25 years old. Which chart do we even go to? That should be your first question. And that's indicated in the title of the second chart, the bottom chart there. That's capturing the population 25 years and older. It also has that associate's degree and college but no degree information. So those are the two sectors that we care about circled for us. Beyond this point, we're going to use a trick that we've already used or a shortcut that we've already used today. We don't have to figure out percent, take 7% of 196,305. We can just compare those percents because we're taking them out of the same total population of the people in that pie chart. So 20% to 7% to 20% reduces to 7 to 20. The percents don't affect that. And that's about a 7 to 21 ratio, which reduces to 1 to 3. And that would indicate B as the answer. Now, if you're uncomfortable with that approximation there at the end, it feels a little hand wavy to you, notice that we could have stopped at 7 to 20 and looked at the decimal equivalent to that. Okay, so that would be 0.35 precisely. And then just compare that to the decimal equivalent of the ratios in the choices. B is the closest one. All right, so second question on this set, I will shave down the time to account for that. So take 45 seconds on this one. All right, so again, we already kind of know where to go on this when we see that language of people at least 25 years old. We know to go to that pie chart at the bottom because the other chart doesn't specify age. And on this one, we're asked about people that do not fit in certain categories. The first thing to note is that's a lot of categories. I've circled everything but graduate and professional and bachelor's degree. It's a lot less direct to answer the question directly. How's that for irony? You're better off looking at first at the people that you don't care about, the graduate and professional degree and bachelor's degree. Okay? If they account for a total of 27% of the total, then we know that everybody else is going to total up to 73%. And just take them out of the total. That's a great technique to use when asked a complicated question. See if you can approach it from the opposite direction. All right, so now our question becomes, what's 73% of the total in numbers? So you can plug that into your calculator. It doesn't work out even to be an integer, but it's close enough to pick that. Or you could even approximate and skip the calculator altogether. We know 73% is a little bit less than 3/4 of a little bit less than 200,000. So the answer we expect is going to be less than 150,000. But only by a little bit. So B is the answer that fits that bill. All right, question 3 on the same set of charts. Take 45 seconds. I started to feel a little bit mean by giving you only 45 seconds once I started that timer. Why? Because, well, this is the first time we're going to turn our attention to the top part of this set of charts. Median salary in the language of the question points us to the top chart where they talk about median earnings. Same thing. And we also see female, male as our bars in that bar graph. And the question asks about females in certain educational categories. That chart encompasses that as well. So we're going to be paying attention to the high school graduate and graduate professional degree bars. And in both cases, the lighter gray bar, because it's females both times. But I start feeling better about giving you 45 seconds because of one other word in this question, and that is the word approximately. Plus, the answer choices are really round numbers, kind of far spread out. So there are some shortcuts you can take. What this question is really asking is what's the percent increase from high school graduate? And we can read off the chart that's a bit over 20K for salary to a bit over 50. So notice that that's very approximate, right? I'm not saying that's 22,000 versus 52,000 because we just, this chart isn't labeled well enough for us to determine exactly what those values are. One thing you might note is that the shorter gray bar that we've highlighted here sticks up above the 20,000 line about the same as the green bar sticks up above the 50,000 line. I don't know. It's kind of an approximation, but it's the thing that lets me determine, oh, okay, the difference between those two bars is about 30K, over 50,000 minus a little bit over 20,000. And we're comparing, we're using the percent change formula. So what is 30K when compared to the original value of a little over 20K? Well, it's a little less than 1.5. And so that means our percent should be a little less than 150. D is the closest answer. If that feels a little hand wavy to you, you could take the opposite approach of using the choices. So what is 140% of the average salary for female high school graduates? Figure that out and see, if that puts you in the ballpark when you add that on to get the graduate professional degree average salary. I'll do that for us just to show how 160% can't be right. So 160% of, let's say it is 22K, rather than saying it's just a little over 20, let's just pick a number, a little over 20. Calculate that, add that, that's how much more the graduate and professional females make in their average salary, and that would put them at 57.3K. And we can tell that that's way too high on this graph. We can tell that. All right, new set of data. First question on it. So I'm going to give you a minute 45. If you have extra time after answering this question, spend some time observing the data. It may come in handy on the next question. This is probably our least straightforward question yet. We have two charts, one stacked bar graph, one table. And this question is the first that's going to require us to look at both. So let's take a look at what we're finding here. We are looking at people aged 45 to 54 years and their expenditures on household furnishings and equipment. So that is a little subcategory in the breakdown of the housing expenses down at the very bottom. And we want to make sure we look at that row and the column for the 45 to 54 year age group. So $1,956 is the amount we're looking for in dollars. Now here's the problem. This asks about what percent of income, and no income is given for any group. There's no dollar amount for us to compare 1956 to. So we have to rely on something else. Where else do we find the 45 to 54-year-old group? They're up in the top chart as well. And notice that what we can find there is their housing expenditures, that bigger category, kind of the category in which we find the household furnishings and equipment. We see that housing category in two places. So in the top chart, we can look at that bar or that segment of the bar to figure out what percent of the overall income. This is our only relation to income that we'll be able to find. And this looks like about 24%, maybe a little less than 25, just kind of eyeballing this. And we also know that housing total is $19,562. Now you could figure out total income from those two pieces of information together. 24% of what is $19,562. But there's a faster way, and that is to note that the category we care about is exactly, actually, we're very, very close to 10% or 1/10 of the housing total. So if the housing total is 24%, our answer's going to be 1/10 of that, and D's the answer. So a lot going on. We had to use both charts in tandem. We may not have found the information we might have originally looked for. Total income simply wasn't here. Tricky question. Here's our second question on this same set of data. For this one, you're a little bit more familiar with it, so I'm going to give you a minute. All right, this time we care about people who are 65 years or older, and we find them in both charts as well, right? They're the top bar in the top graph, and they're the rightmost column in the bottom graph. And we're looking at percent of income. On the last question, we got closest to that by looking in the top chart. And what we might notice as well in the top chart is that if we go looking for utilities as a category, it's not there. So we have to hunt a little bit. Utilities are actually found down in the bottom chart. It is one of the subsets of the housing expenses. And so at first it might look like this is shaping up to be a similar kind of problem to the last one. Looking at 3314 is the dollar amount spent on utilities, fuels, and public services by people in the 65 plus category. But all of that would be wasted effort. There's one little trick going on here. Utilities is lumped together with other expenditures. We cannot sort that out. What's utilities and what's fuels. And so the answer here is A. Make sure you're looking at the right category, precisely the right category. All right, last question on this set. Take a minute on this one. All right. How much more do 25 to 34-year-olds spend on housing than on food? A few categories to note there. The age group and also the categories of expenditures. Housing and food, we're not focused on the nitty-gritty of housing anymore. We're comparing the broad category of housing to the broad category of food. And so we're looking at the top chart. But they do ask about dollar amounts here, and really the only dollar amounts we have to go on are the housing dollar amounts. So we do have that total of $17,318 to work with from the bottom chart. All right, so how do we get from, housing being 28% of income and also equaling, 17,300 in dollars? Well, a shortcut is you don't have to necessarily figure out the total income for people in this age group. You could do that by dividing $17,318 by 28% or by 0.28, and that will give you their income. And then you'd take that income, multiply it by 0.11 to find out what they spent on food. But what we could do as a shortcut to that is acknowledge, both the 11% and the 28% are taken out of the same total income. So, we could look at the ratio, right? These people spend 11/28 as much on food as they do on housing. Okay, and go straight from the housing dollar total, using that ratio, to the food dollar total. And don't forget, they're asking us for the dollar difference. How much more do they spend in dollars on housing than on food? So there's a final subtraction to be done. That doesn't quite match up to any of the choices, but D is closest. Now you may be saying it's not close enough for me to feel comfortable with it. And plus, aren't you being overly precise as you pull these numbers off the chart? These are only labeled in 10% increments, right? And you're telling me this is 11%. How do you know? That's not quite satisfying to me. 28%, yeah, I get that this is a little bit over the 10% mark. You can tell that at least. This bar for housing ends a little bit shy of 40%, but how do you know that's 28 exactly? And the answer is I don't, okay? So you could take a less precise approach with the numbers, so clearing that all off. We'll still go to the same place to look for that data, but this time I'm not assuming anything, except for the fact that food is more than 10%. We can tell that from the graph, and housing is less than 30% of income expended. All right, but the same kind of shortcut applies. 25 to 34-year-olds spend less than 3 times as much on housing as on food. I'm comparing something short of 30 to something a little higher than 10. Clearly a little little less than a multiple of 3 to get from one of those to the other. So set up an equation. And here LT just stands for less than. So housing is less than 3 times the food amount. We can use that to solve for the food amount. And when doing 17,318 divided by less than 3, just plug into your calculator the number part of that. The fact that you're dividing by something less than 3 means that the result is actually greater than what your calculator spits out. Dividing by a smaller number leads to a higher result. And so, again, we have a dollar amount for food. Here the difference is a little bit less than 11,545. And again, it's an approximation, but notice that this number is, we approximated about 500 high. By the last method, we approximated about 500 low. Pretty clearly, D is probably going to be in between our two approximations. I think that one is a tough one by GRE standards. For the most part, you won't have to solve it twice to be able to approximate. And that brings us to our conclusion. Just make sure before you dive into the values, you know what's what. So pay attention to the words and really pay attention to the distinction between percents and real numbers. And if they're real numbers, think about what the units are on them. Are they metric tons of soybeans, or are they people at a party, or students at a school? Are they dollars? When you deal with percents are meaningless unless you know what they are a percent of. So one shortcut we took here was, only having to compare percents, but that was only because they were percents of the same amount. If they were percents of a different amount, we wouldn't have been able to do that. Don't convert to real numbers unless you have to. Sometimes you could just look at a percent difference and then calculate the correct amount. I want to emphasize this one. 3 is 150% of 2, but it is 50% greater than 2. Percent of and percent greater than are always different by 100%. Greater than implies you look at the difference between the two numbers and then take that as a percent. So it is a smaller amount. In questions like the one we saw 2 questions back, if cannot be determined is an answer choice, think very, very carefully about what would make that the possible answer. Confirm your calculation. If you come up with a number on that one, before you pick it, make sure it is right. And anytime you use a calculator, anticipate what the answer should be. Do a sanity check on the number that you get out of it. Enjoy doing these practice problems. Good luck.